Okay. Screen, can you see the screen? Can you see the screen?
Yes, sir. It will landscape also.
Okay, so before your midterm, we studied mainly about biomedical imaging techniques. Okay, different biomedical imaging modalities, particularly two of them. We studied X-ray and ultrasound imaging. These two are the most common imaging techniques. There are some other techniques that are also used. One is MRI, okay, that is called magnetic resonance imaging. Also, you have PET scan. PET scan stands for positron emission tomography or single photon, something like this, ECT. আর হচ্ছে কি আছে optical coherence tomography, OCT. আচ্ছা, so these two are the most common, and I believe you have some understanding how we actually perform X-ray, CT scan also, X-ray, CT scan, ultrasound. Now, MRI, we actually use radio frequency and some operations in the magnetic resonance of hydrogen ion. Achha. PET scan is actually a bit different. These two are called nuclear medicine. These two are called nuclear medicine in nuclear imaging, because you see in these two scenario, you actually some nuclear material is actually injected in your body. They actually emit gamma ray, and you capture those things using some gamma camera. Your body emits something that so the material that is inserted in your body that emits some gamma ray, you try to capture it. Okay, that is the PET scan or SPCT SPECT. And OCT is like you use infrared ray. Okay, so everyone has some specific purpose of these ones. So we are not going to discuss these things right now. If we have time towards the end of the course, we'll discuss some of them in briefly later. Okay, because we have lots of other things to cover. Now, this is actually biomedical imaging. All the techniques normally actually covers in this part. Achha. Also, we also discussed about predictive modeling. And we discussed in detail almost how you can use CNN. If you have some images, how you can use actually CNN architecture to perform any kind of prediction task, whether it is classification or segmentation or anything. You can actually do those things using CNN architecture. And I believe you have some good understanding of CNN architecture so far before this midterm. Achha, from the discussion. Now, after midterm, some specific things that we need to actually finish. One of them is biomedical signals. You see, biomedical signals, there are different signals that we actually measure. The activity of different signals, biomedical signals, different activity of our body, such as the electrocardiography, okay, the activity of the human heart, okay, then electroencephalography, okay, electromyography. So we are going to talk about this one, at least two of them, at least. There are several, there are 3 or 4 or 5 EMG and others. We'll at least try to talk about 2 of them at least in particular in details. Then you have image processing. Okay, image processing. You see, so far we have talked about the imaging techniques, the imaging modalities, and predictive modeling. There is, before this predictive modeling, we do something. Some processing techniques are there to enhance the image, enhance the quality of the image, then filter the image, okay, other things, among other things. This is something we do before performing any kind of predictive modeling. So we need to discuss about this one first. So we are going to talk about this one. We are going to start with this one. And last 3 is signal processing. Signal processing. So these signals that you have, ECG or EEG signal, how to actually process those signals using okay, using MATLAB, how we can actually do those things. So we are going to talk about these things in the last. Okay. So you will have one lab, I think lab 4 based on this one, and inshallah lab 5 based on this one, hopefully, if we have time, enough time. Now let's start with image processing. Starts with image processing. Any questions so far? Now you see the acquired images that you get from either your X-ray bolo, your MRI, or your ultrasound, whatever you have. Okay. The acquired image, based on the like measurement type, the image can be a little bit noisy. It can be a little bit blurry sometimes. Okay. Or not enough contrast. Okay. Not enough contrast. Depending on device, many of the things can actually happen. Okay. The for the image, there are many things can be happen. Also, on the accurate image, you can actually want to perform some specific task. You might also want to perform some specific task. For instance, highlight certain segment or certain region. Highlight certain regions, such as the tumor. Okay. You have the image, maybe a good image. In the good image, you may also want to highlight the tumor so that you can actually properly understand, visualize it. Not just predictive modeling, even just for visualization, or even for the like the doctor or the physician to understand properly. Okay. So you perform this task before you actually make a decision, before you try to make a decision. Even the clinicians tries to make a decision. You want to do this kind of processing task. Okay. Image processing by image pre-processing, actually. Processing task that you want to do. Okay. So for this type of task, you have different techniques that you can actually perform. Okay. There are lots of techniques you can perform. We are going to see some of the common of them. Common means, you see, in terms of this, there are some common and some specific. There are some techniques that are very specific to ultrasound imaging. Okay. Very specific to MRI imaging. Okay. Because those images are different types. So for ultrasound imaging, there are different specific techniques for that one. So discussing those things does not actually fall under this course. So we are not going to go to a specific, but we are going to talk about the common technique that you actually use for any of the images that you actually collect for biomedical scenario. Okay. So we are going to talk about the common techniques that you actually use. So for instance, the enhancement technique. So image enhancement is one of the things that you actually want to do whenever you have some acquired some images. You want to perform some enhancement. Okay. Now this enhancement, this can be divided into two types. One is point processing. Another one is mass processing. Okay. So point processing and mass processing. Point processing বলতে যেটা what is meant by point processing, you see, in point processing, each pixel like is processed or modified, okay, to get the processed pixel. And here lies a one-to-one mapping. One-to-one mapping বলতে বোঝাচ্ছে, see, if you have this value, this is like this way. So let's say this is your pixel values. So whatever you have here, this is like x comma y, your pixel value. When you process the image to convert this one, okay, to convert this one to x prime and y prime, you will only change this value. You do not consider any surrounding pixel values. Okay, that means whatever you change, you make it x prime to y prime. So x comma y value is changed to x prime and y prime. It is changed only based on whatever the value here is. You do not look at any surrounding pixels. Don't look at any neighboring pixels. So this is called one-to-one mapping. Okay, whatever the value is, you directly this one. Again, same thing for this one to this one. Okay, you don't look at anything in the other than that point, specific point. That's why this is called point processing. But what in mass processing? In mass processing, you actually consider neighborhood pixels. You consider neighborhood pixels, and ultimately for this one, you consider all the pixel information, then get to this one. That is your mass processing. Is the difference clear? So, is the difference clear?
Yes, sir.
So these are two types, mainly divided, categorized into point processing and mass processing. So this mass processing is actually the filter operation. We have already seen in the convolution type convolution filter. This is actually the same thing, the filter operation. We'll talk about mass processing. And point processing is just direct processing the images. Let's talk about point processing first. Okay. There are different techniques. So you see, the purpose of this one is improve the quality. Improve the quality. For max processing, the purpose is usually a little bit different. You will see when you actually talk about this one. For point processing, the main purpose is improve the quality of the image. Okay. Improve the quality of the image. So your image can be of low quality, image can be a little bit noisy, things like that, or less contrast. You want to increase it. You want to improve the quality of the image. That's the main purpose of point processing. And how do you do that? You actually manipulate the gray level value of the image. This manipulate the gray level. What does it mean? You see, number one type of technique is contrast enhancement. Very common. So contrast means it is actually the visibility. So if you enhance the contrast, that means you are trying to enhance the visibility of the. So mainly we talk about the grayscale. Grayscale image. I believe you already know what is a grayscale image. In grayscale image, you have values from 0 to 255. Okay. So this 0 is actually response to black, and this 255 response to white or bright color. So in the image, if you have some dark regions, that means the grayscale values are closer to 0. And the bright regions, the grayscale values are closer to 255. If you have seen the signal processing, digital image processing lab manual, okay, or the MLX file, you will see this difference. Acha. Now you see it can happen that your region of interest, such as the tumor, okay, your region of interest is like in the range of 20 to 30, the values that you have in the whole image. Your region of interest, the pixel values, these are the pixel values, are in the range of 20 to 30. Okay. So that means you see the difference between these two is actually very limited. What if we stretch the image? Stretch it and make the pixel values from 20 to 60. Okay. You just divide it. Okay. 20 টাকে 20 করে দাও, 30 টাকে 60 করে দাও, And whatever the values you have in the between, you just change it that way. So if you have something like this, let's say this is 20, 30, this is 25. When you process it like this way, this 30 becomes 60, 20 remains 20, this 25 becomes 40, things like that. You change it in the same proportionally. Okay. So you are stretching the gray level. Okay. So what you are doing here is stretching the gray level. Okay. So when you are stretching the gray level, you are getting a bit wider range. So what will happen when you have the wider range? So when you do it like this way, when you stretch it like this way, you see the differences in this 20 to 30. When you are in this range, 20 to 30, the differences in the pixel values may not be very clear. But when you stretch it, now you see 20 to 60, you can see the difference of every pixel. So you can actually differentiate between the regions in between very clearly, more clearly, not extremely clear, but you can actually make it better visualization if you actually stretch the image like this way. Okay, this is what you do in contrast enhancement. Are you following?
Yes, sir.
Okay. So in the lab 4, I'll show you the effect of each and every one of them. Okay, I have to correct some images, but I will try to show you every and each and every one of them, how a normal image, if I perform contrast in enhancement, what will happen to the image. Okay. Acha. So, why do we use it? We can use it for tumor. Okay. So your tumor is actually surrounded by other organs. So compared to those things, usually the tumor is more darker, or সাধারণত darker হয়. So compared to the other regions, the tumor is usually darker. So if you perform this kind of contrast enhancement, you can separate these regions from these regions more clearly. You can see the difference more clearly when you stretch the values, the grayscale values. Okay. Is it clear?
Yes, sir.
Any question? Binarization. You already know about this idea. The purpose of this one is separating an object from the background. Okay. So separating an object from the background, sometimes what you want to do, you just want to have like, you have two particular things that you want to do. So you just separate them. Okay. You separate this one, you make it like black and white. Let's make it black. And the background is black. Okay. So you can just see the object, the shape of the object like this way. Okay. And you do this using thresholding. You already know this thresholding approach. So using this thresholding, you just separate one object from the background objects. Okay. So when you do this, the shape of this one you can see very clearly. Shape of this you can see clearly, and the background you don't want to visualize. No need to visualize because you have made it completely black. So if you have the image like this, all black, yeah, okay, you have this all black regions, and মাঝখানে you are just, if you are using like this way, in the middle you have this shape. Okay. And the surrounding area is all black. All the surrounding area is black. So whatever you have in the surrounding, you don't understand, you cannot know. You can only see the shape of the this region. This is the foreground. Okay, that is the purpose of binarization technique. Okay, you choose some threshold value. You know the different methods that we actually have. You choose the threshold value, and then you separate different things, different objects like this way. This is another thing that you want to do sometimes for some applications. Now for instance, for this application, can you use binarization? Your tumor is surrounded by organs. If you want to visualize, do you use binarization? আমরা কি ইউজ করবো?
It depends on the contrast of the tumor.
Contrast of the, বলো কেন, একটু একটু ইলাবোরেট।
And sir, binarization, sir, basically এখন টিউমার যদি সারাউন্ডিং অর্গানস এর চেয়ে ভালো কন্ট্রাস্টই হয় তাহলে বাইনারাইজেশনটা কাজ করবে, বাট কন্ট্রাস্ট যদি কম হয় তাহলে বাইনারাইজেশন ইউজ করলে ভালো ইফেক্টিভ রেজাল্ট
আচ্ছা,
আসার কথা না।
so you see, if the tumor, ও যেটা বললো, if the tumor is like very clearly distinguishable from the rest of the organs, you can use binarization, then it will work very well and you can very easily see the shape of the tumor. So if your purpose is to understand the shape of the tumor, okay, then you should use the binarization technique. But also, if your purpose is to like understand where the tumor is located, okay, compared to the other organs, then you will not use binarization. ঠিক আছে? If you want to understand the location of the tumor, where the tumor is located compared to the other organs, okay, how sensitive the tumor is, okay, how big the tumor is compared to the other organs, in that scenario you will actually perform this contrast enhancement. You will not perform binarization. The purpose of binarization is very specific. You want to understand the like the area of the object, things like that. That is when you actually perform binarization. Okay. আচ্ছা, completely segment one particular space. Okay. It depends on the application, what you want to do. Okay. আচ্ছা, number 3, bit level slicing. আচ্ছা, so when you talk about these values, you see 0 is represented by 0000, 255. They are represented by binary value, তাই না? So 8 bits, that is equals to 1 byte. Now this one, the leftmost one is called the MSB, most significant bit. The rightmost one is called the LSB, or least significant bit. Why do we say it the most significant bit? You see, if I change the MSB from 1 to 0 and make it like this, the value has changed significantly, right? These two, there is a major difference in the value. So in the MSB, any change in the MSB will significantly change the information that you have. But if you change the LSB, all are 1111, 1110, the change is very minor. 255, it is like 254 হয়ে গেল. Okay, very minor change. So that's why it is called least significant bit, because it does not actually affect much. Your image information is not affected much. Is it clear? So the idea is, you see, the most significant bits, they actually contain like more information. Least significant bits, less information, things like this. So what you can do, scenarios like this, let's say, keep only 4 MSBs. So out of this 8, if I want to keep only the 4 MSB, what will happen? This will become 11110000. Okay. So from originally it was 11111111. So the change here, if you make it like this way, you see the change is not very significant. A small change is there. Okay. So in bit level slicing, we actually do it like this way. We change, we keep some of the MSB, make others change the other things like this way. You can also do it like this. You keep only 1 MSB. You keep only 4 MSB. You can keep only the first MSB. Only the first MSB. But if you keep only the first MSB, so if you make it like this way, you are going to lose some information, right? It will result in some loss of resolution. So in bit level slicing is actually like this. You keep some of the MSB and let go of whatever the LSBs are. So you can see why do we do this? Number one, this way you can compress your image. So sometimes if the image data is too large, okay, it can be like one image is like 20 MB, very large. What you can do, you can take at least only 2 MSB and let go of all the others. Okay. So in scenarios like this way, what will happen? Your image size will reduce, variation will reduce. Achha. Number two, this one will convert gray to binary. You see, in this scenario, in this thresholding, we actually add some value. We say like, let's say 25. Anything greater than 25, you make it white. Anything less than 25, you make it black. This was thresholding based binarization technique. For this one, you have to find this threshold. But you see, if you want to do this, create a binary image without finding the threshold, what you can do, you can actually convert gray to binary using this kind of bit level slicing. So what you do, you keep the MSBs as 1, make the LSBs as 0. And this will change the like least significant bits, convert them from white to black. So it will convert, make a binary image without changing too much information. Without changing too much information, you can convert a gray image to binary image like this way. Okay, so your image will be similar quality, not very large difference, but with lower size and lower variation. So in this way, when you actually do it this way, what can happen? You see, gray levels that are more important will be highlighted. When you do this binarization, convert a gray to binary like this way, the gray levels that are important will be more highlighted, and some of the this least significant ones will be suppressed. Okay, so you will get a more distinction between two levels like this way. So this is something very simple kind of modification. You sometimes use this kind of things. In the lab, you will see how the effect of bit level slicing actually works. Any question? Now, last one, histogram equalization. So this is actually the most popular. Okay, this is actually the most popular, one of the most popular techniques we actually use. Histogram equalization, one of the most popular technique that we use. What is histogram of an image? কে বলতে পারবে? What is histogram of an image?
স্যার একটা গ্রাফ দেয় আর কি ওই কন্ট্রাস্টের উপর বেস করে প্রত্যেকটা পিক্সেলের।
So you see, whatever the pixel values are, you put a graph like this way. So how many pixels? 0, 10, 20, 30, 40, like this way. How many pixels had 0 values? How many pixels had 10 values, 20 values, 30 values, like this way? You put a graph like this way. This is the histogram, image histogram. In the lab, you will see what image histogram looks like. So what do we do in histogram equalization? Let's give you a scenario. For instance, say for instance, you are taking cell images from microscopes. You take cell images from microscopes. Now, say for instance, you are taking the cell images from microscope. Let's say same cell. One of you are doing it in the lab, sitting in, let's say, Notre Dame College. Okay. Another one student is doing the same cell in another microscope in MC College, selected MC College. Another one is doing it from Azizul College, Bogura. Okay. So you see, you have the cell image. You are performing this experiment in 3 different colleges, 3 different microscope. Also, the illumination setting. Okay, in the lab, the illumination of the lab, তিনটা ল্যাবে কি সেম হবে না ডিফারেন্ট হবে? সেম হবে না ডিফারেন্ট হবে?
Different.
Different, because you see the lab environment, the illumination, everything should be a little bit different. Microscope will be different. So even in the cell images, so even if you have the same cells, the gray level of those images same হবে না different হবে?
Different.
Okay, so you might have the same cell, but due to this difference in the illumination, the gray levels will be different. So for instance, if you are let's say in Notre Dame, say there are everything is very light. Okay, so the values are like around the range of 200, 180, 195, like this way. The same thing you are doing in a very darker region, the values are very close to 100. Okay, 100, 94, 90, 92, or some things like this. So you see the information is there, the information will there, but gray levels values will be very different. So in scenarios like this, say if you are trying to like develop a technique based on the images on this training on the images on the Notre Dame College, that technique is performing well on the microscope images that is actually using in the Notre Dame, but that same technique will not work properly on the images that you have taken from the Azizul Haq College microscopes. Why? Because these things change in microscope, changes in illumination, change in the grayscale levels. Okay, so this will happen. Okay, so same technique might work well for one set of data, but it might not work well for another set of data. Okay, so the less variation is there. So that's why you want to change the variation. So difficulty, it will create some difficulty in comparison. Okay. So what do we do to solve this problem? We try to equalize the gray level. Equalize gray level distribution. So you see, when you have a little bit dark images, values are close to 0. So the histogram energy, the histogram that you have, they are on the left side. In the bright images, values are close to 255. So the values are very close to the right side of the histogram. When you equalize the distribution, it means something like this. So you see things like this, if you have like this. So if you equalize it, whatever you have, you try to make it in the similar distribution. Okay, the whole range should be distributed like this way. The values that you have, even the small values, they should be like equalized to the whole region that you have from 0 to 255. You equalize the value towards the whole region. Okay, in the lab, I will show you the difference in histogram equalization. What happens in the normal scenario? What happens if you have performed this kind of equalization? Okay, so you actually do this one before any type of image processing. Like if you have to have some batch processing. So what do? You perform this histogram equalization. So to make all images have somewhat equivalent, somewhat uniform distribution. Okay, so if you perform this histogram equalization, all the images will be in the similar range of histogram, will have similar uniform histogram. Okay, so that's why you want to perform this histogram equalization, and you actually try to apply those things before a normal processing step. When you actually try to develop an algorithm for a particular image, like you are trying to, if you're using DSP in digital image processing, if you're trying to perform something for one particular image, so you want to test it for 2-3 images, then make it automate it for 1000 images. So you check your images for 2 and 3, based on this you perform some values, then automate it for 1000 images. For this kind of task, you try to actually perform this kind of equalization so that all the images have similar level of histogram. Okay. That will make it much more clear. Otherwise, for some images your model is working, but in many of the images your model will not work properly. Is it clear?
The last part আরেকবার বলবেন তো please.
লাস্ট পার্টটা হচ্ছে লাইক, সো ইফ ইউ ম্যাটল্যাব ব্যাচ প্রসেসরের সাথে তোমার কাজ করছিলা?
না স্যার, এটা নিয়ে কাজ করিনি।
ম্যাটল্যাব ব্যাচ প্রসেসিং একটা অ্যাপ আছে। ফর ইনস্ট্যান্স থিংক অফ ইট দিস ওয়ে, when you are doing this thresholding, মনে আছে থ্রেশহোল্ডিংটা?
জি স্যার, মনে আছে।
আচ্ছা, ইন দ্য থ্রেশহোল্ডিং আমরা কি করছিলাম? You are trying to find a crack in the wall, right?
Yes sir.
আচ্ছা, so you find it for one particular image or two image, but you don't want to do it manually for each and every one of them, right? You want to do it for, like, you have 2000 images, you want to perform it for one or two images, then automate the process so that it can do it for 2000 all the images. But you see, all the 2000 image will not have same level of illumination. Okay, so whatever is working for this one or one or two images might not work for all images. So to match it so that all the images have similar distribution in the gray level, you perform this kind of histogram equalization. Then whatever you have for this one will work for most of this one. আমার কথা বোঝা গেছে? ওকে,
বেসিক্যালি
দ্যাটস
স্যার
দ্য
একটা
আইডিয়া।
ফাংশন ক্রিয়েট করে দিচ্ছে, ওই ফাংশনটা সব
হ্যাঁ, ওই
ইমেজে
ফাংশনটা যাতে করে সব ইমেজের জন্য মোটামুটি কাজ করতে পারে। তো ইকুয়ালাইজ করলে মোটামুটি সব ইমেজের জন্য ভালো মতো কাজ করবে আর কি। আচ্ছা, এনি মোর কোশ্চেন? So this is all about your point processing. Okay, these are like very common one. Okay, there are different histogram equalization. We have talked about only one of them, because histogram equalization. There are adaptive histogram equalization. Okay, difference in different type of histogram equalization techniques. So there are lots of image processing techniques. Like I said, we are going to talk about the most important one, just because you have some idea of this kind of processing techniques. Okay, so these are all about the point processing techniques we discussed today. In the next class, we'll talk about filtering, mask processing. Okay, any question? Acha, so let's finish today. You can actually you can write your student ID in the chat. So your next class tomorrow, I think IT has admission test. So Thursday কোনো ক্লাস হবে না, ফ্রাইডে কোনো ক্লাস হবে না। Thursday and Friday classes, মানে they asked me to take the class online. So tomorrow's theory class, section B, it will be also be taken online with the other sections.
ওকে
Okay,
ওকে স্যার।
section B এর সিআর আছে, ওর পি আছে?
জি স্যার।
সাকিব, হ্যাঁ একটু জানাই দিও, কালকে সকালে ক্লাসটা হবে না।
আচ্ছা স্যার।
আচ্ছা। Okay, I think let's finish this one.